channel, and this is the first whiteboard video you're going to have. Now in this particular experiment, I'm breaking it up into two whiteboard videos. I'm going to do one on measurement and significant figures and the other one on drawing graphs. And you can see I have to the left here, I have the experimental background, which you have in the module pulled up so you can read through that as we go along. A lot of this is taught to you in the lecture, but I'm going to give it a go and just kind of do this enough to help you do the experiment. All right, and we'll just kind of go through. The procedure is in here as well. You don't need to, obviously you're not going to do the experiment, but it will help you understand a few things. All right, so measurement, all measurement has three, not all, but most measurement has three pieces of information. And two of them I'm not really going to spend much time on. There's the value, which is the number. So, 17. There's the unit, and here we use the SI units. All right, and that's in the background, it's over here. We talked about on the first page, actually, right? Just meters, kilograms, things like that, right? We always use that. In this experiment, the units are put in for you, but in ensuing experiments, I believe starting with experiment 3, we won't have the units put in for you. So that's something you want to get in the habit of. If you write a number without a unit, it's -1, -1, -1. And that's really important because if you measure something and it's 5 kilograms versus 5 grams, right, a very big deal. Or even pounds versus kilograms. But the third part is the uncertainty. Or error. Really bad handwriting. Okay, and this is Sig Figs. And in your lecture, you should have had something like this. Sig Figs are all measured values plus one guess. Now it's actually going to be easier for me to do this using the background to the experiment than actually writing on the whiteboard. But let me explain what I mean. So let's look at this figure here. All right, if you look at this diagram here on the left, we're going to measure how long this darkened bar is. You'll notice that when we have the units of measurement, and let's say that this is all meters here. I can't write on that. I'm sorry. When the marks on the ruler, okay, are every, let's say this is meters, are every 1 meter, we can say the distance, again, looking over here on the left, is somewhere between 3 and 4. Don't look at this one on the bottom. It's somewhere between 3 and 4, right? And you'd say, well, maybe it's just, it's not quite 3.5, but we're going to say it's about 3.4. All right, and so what that really means, though, is we're sure about the 3, but we're guessing the 4. So I'm going to put just an arrow on my guess here. All right, and so what this means is this is the plus or minus the precision, which is the plus or minus value. And the precision here is what my guess is. It's plus or minus 0.1 meters. So what this really means is that this is between 3.3 and 3.5 meters. All right, now, if you look at the ruler on the bottom here, you see between the 3 and the 4, there's a mark every 10th. And so we're going to say the marks are now every 0.1 meters. That's a 0.1 meters. And so now we can say, well, this is 3.4, and it's further than that. That's 3.5. So we're going to say it's 3.45. All right, and now in this case, we're sure about the 3 and we're sure about the 4, but we're guessing the 5. So I'm using an arrow to indicate the guess. That means that the precision is plus or minus 0.01 meters. And so what this means is it's between 3.44 and 3.46. So this is actually more precise. Now, if I was to take this and make a whole bunch of little marks in between, right, which I can't do on this document, but I can mark it off one more, and then I would carry it another digit. So what's important to realize is that we always record one decimal place beyond the guess. I'm sorry, one decimal place beyond the marks. Right? And so it was marked off in ones, we recorded to tenths. It was marked off in tenths, we recorded to hundredths. And then the last, then we guess between the marks. And that last decimal place is the guess, and it's plus or minus 1 in that decimal place. So here, the guess was in the tenths, so it's plus or minus a tenth. The guess is in the hundredths, it's plus or minus a hundredth. All right, so all of those numbers, all measured values plus one guess, are the significant figures. I'm going to clear this, so you can hit pause for a minute if you need to. Now, significant figures, as I said, I'm going to make this pen just a little bit thicker. How about that? Let's go to there. Right. Significant figures, as we said, are all measured values plus a guess. The problem with significant figures is when we have numbers written, how do we know how many significant figures? But let's back up. So if we have a ruler, right, let's say that our thermometer the marks are 1 degree C, we would record to 0.1 degrees C. All right, a cylinder, a graduated cylinder. The marks are 1 mil, we would record to 0.1 mil. So you always go one decimal place beyond the marks. And that tells me how precise it was marked. Right now, the other thing about significant figures is when we record numbers, how do we know which numbers are significant? And that's where you can look over here. The only problem we have is with 0, because if I write 5.0, that means that that 0 is a guess. So, but what if I write 50? Whoops, what if I write the number 50? That 0, is it a guess? Did I measure, or is it just a placeholder? So really, these rules for significant figures are to deal with 0. So if you look over here on the left, right, all non-zero digits are significant. Okay, that means anything, you wouldn't write a 5 if it wasn't either measured or guessed. Zeros between significant figures are significant. Zeros after a sig fig and after a decimal point are significant. So what that actually means is placeholders are not significant. All right, so I'm just going to erase this for a minute here. Actually, let's clear all. All right, so now, for example, if I do this, if I write the number of sig figs, and then what's the plus or minus just for fun? Okay. If I have the number 303, that has 3 sig figs. The 3 is the guess, and it's plus or minus 1. So that means it's between 302 and 304. This is what it means. All right, if I have the number 3.1, that has, I'm sorry, 3 point, yeah, what's it like that? No, 3.0. Sorry, 3.0. This has 2 sig figs. That 0 is significant. All right, because why would I write it? And it's after a significant figure and after a decimal point. So this is plus or minus 0.1. So this is between 2.9 and 3.1. If I have the number 207, okay, that 0 is between, that 7 is a guess, the last sig fig is the guess. 3 sig figs plus or minus 1 is between 206 and 208. Now what if I have the number 0.026? All right, well, that number is a placeholder, and a really easy way to tell is if you cover it up, does it change the value? And if you do, it does. That 0 is after a significant figure, but it's not after, it's after a decimal point, but it's not after a sig fig, right? So this only has 2 sig figs. It's plus or minus 0.001, so it's between 0.027 and, 5. And 0.027. Now, what if I have the number 300 written like that? That number has 1 sig fig, the way it's written. Okay, the books will tell you that you can't tell, but I'm going to tell you can tell. This means it's plus or minus 100, and so that means it's between 200 and 400. Now, okay, but you get the idea, and it's a practice thing. Now, what if I meant these zeros are significant? How do I write 300, but I mean 3 sig figs, right? And the answer is, best way, scientific notation, 3.00 times 10 to the 2. Now the zeros are after a sig fig and after a decimal point, right? Or you could write it like this with a bar over the 3. That's another way. Just to summarize, 300 written this way in scientific notation is 3 times 10 to the 2. That's 1 sig fig. That's plus or minus 100. That means it's between 200 and 400. If I write 300 with a bar over the first 0, that's going to be 3.0 times 10 to the 2. That's 2 sig figs. That's plus or minus 10. That's 290 to 310. If I write 300 with a bar, 300 with a line over the second 0, that would be 3.00 times 10 to the 2. That's 3 sig figs. That's plus or minus 1. That's 299 to 301. And then the last one, if I write it like this, 300.0, I don't have to do anything, right? Because that's after a sig fig and after a decimal point. And so this would be 4 sig figs plus or minus 0.1, and that's 299.9 to 300.1. So you can see writing the same number different ways means different things. All right, so if you want to hit pause to think about this for a minute, you can do that. All right. Now I'm going to go through sig figs and operations, and I'm going to go through the lab itself. All right, I clear this. So how do I handle sig figs and operations? So when I add, subtract, I make 2 measurements. All right, and this is explained over here. It's explained starting with equation 3. And actually, I'm going to just use that to do it. Well, I can do it I'll use this to do it. Okay, if you look over here. But the bottom line is that you're only allowed 1 guess. And so what you do is you do the math and then you cut it off after the first guess. And then round appropriately. After. For addition and subtraction, you should just remember that. So if you look over here at equation 3, see how this number here, the 36.21, the 1 is the guess. So these ones are in bold. Here the 8 is the guess. So when I add these together, if I'm not sure about the 8, I can't even talk about the 1. So now I have 2 guesses here. So I would cut it off right there. All right. You can also, you see the sig figs can change. Down here, I'm going to add, both these numbers have 2 significant figures. See that? 9.1, 3.4. When I add them, my guess is in the 10th place. When I add them, it's a 5, still in the 10th place. So then I have 12.5, but you see I picked up a sig fig. Okay, this page got cut off. The 1.98 should be here. right? Just to show you also, if I take these numbers, your sig figs can drop. If I take 12, whoops, why doesn't it want to write? There it is. Okay. If I take 12.6 minus 12.4, right? Both these have 3 sig figs, but my answer is 0.2. So I dropped to 1 sig fig. When you multiply and divide, when you do that, really the answer has the same number of sig figs as the number with the fewest. So if you look over here, look at equation 5, this number has 4 sig figs, this number has 3 sig figs. My answer, my calculator's a liar. My answer can only have 3 sig figs. Okay, here on equation 6, these two numbers should be here. Here I have to do this math in here, so when I do this, I'm going to cut it off at the 10th place, so the 8 is the guess, all right? And then I'm going to divide it by a number with 3, and number with 3, my answer should only have 2 sig figs. So you drop down to the fewest. All right, so that's going to take care of significant figures and the addition, subtraction, multiplication, division. Now I'm going to kind of go through the procedure. And some of this data is going to be provided in the data section. Some of it's in the videos kind of show you how things are done, but some of it will be provided in the data section. And actually, as I'm doing this, I don't have all the data yet. My colleague is sending it to me. All right, but just to show you, if you look at the procedure, all right, what we're going to do for distance, and this one's going to have some photographs for you. But what you're supposed to do is get a piece of paper. So this is part A. You take a piece of paper and you're going to make marks on it. Use this as a ruler. My marks are going to be every 10. You do it with centimeters, 20. But obviously this isn't 20 centimeters. 30, like that. And then you're going to measure your book or a book. And actually what I'm going to do is I'm going to give you a picture of this being measured. So this is the thing we're measuring. Okay, and then you can see that the mark, this is going to be about 22. Then what we're going to do is now we're going to make the marks here. So there's a 5, 1, 2, 3, 4, 1, 2, 3, 4. And now you can see the marks are every 0.1. Let's try that again. That worked. So there's 5. So you can see it's about here now, it's about 22, 23, maybe 0.0. But the bottom line is you'll see that. So you're going to see how they're marked, and then you can do some other things with that. Part B, you're just going to measure temperature. Part B, look at the video. Okay. Now part C, oops. Part C, I don't know how I made that smaller. Oh, I know how I made it smaller. Okay, part C, you're going to measure volume. And just to show you part C, I'm going to go to over here. And this one, I think we're giving you pictures, but I'm not 100% sure. All right, I have to remember, but you'll see if the numbers are will either be pictures or will be given this. But part C, you're going to put some water in a cylinder. A graduated cylinder is marked off in ones. And so the liquid forms this curve here, and that's called a meniscus. And what you're supposed to do is you're supposed to have your eye even with the meniscus like this. And let's say that this said 27. And let's say that there's a mark here 28. And let's say there's a mark here, 29. All right? Oops, 27, 28. How about, let's make that a 26. Jeez, Rob. All right, and so we're going to call this, you see the reading the meniscus, I would say that this is 27.0 milliliters because it's marked 26, 27, 28, so I can guess the 10th place. Then what you're supposed to do, if you look over here, right, you're going to look at the meniscus from way up here. And you're going to look down at it. Now when you look down, see how the marks are on the glass. So you might look at this and you might say this is 27.6 mils. And then you're supposed to do it a third time with your eyes way down here. Really scrub this, and this error is called parallax error. It's error from looking at the wrong angle. But here you'd look, and again, it's where it hits the glass that you read it. So you might say this is 26.8 milliliters, right? So you either be given these numbers or you're going to be have pictures and you're going to look at it. Then what you're supposed to do is calculate the error. I know this is a long one, and again, I'm going to do another one. Now the error is O minus A, where O is your observed, and A is the actual. So let's do this, let's calculate this for below the meniscus. My error would be O, 26.8, minus A, 27.0, which is going to be negative 0.2 mils. Now the negative is important because if you think about this, why would you ever measure something if you already knew the answer? And the answer to that is, well, sometimes you're going to calibrate something. So let's say, when you get on a bathroom scale and it's reading too high, well, how do you know if the error is too high or too low, right? And what do you do with that? Well, let's say the error is too low. This means you're low. So this means you might turn the dial one way. If the error was high, right, then it means you turn the dial the other way. So the sign tells you not only I'm off by 0.2, but which way. The other type of error is percent error. And that is going to be the error over the actual value times 100. Now, by the way, notice here with the Sig Figs, when I did the subtraction, I went to the 10th place. The 8 is my guess. The 0 is my guess. I have 1 Sig Fig. In a calculation, a pure number, like part of a formula, will not affect your Sig Fig. So the 100 doesn't change it. But in this case, my error is 0.2 mils. Over my actual value, 27.0 mils, times 100. Let me get my calculator. So 0.2 divided by 27.0 is 0.7, negative 0.7. So I'm negative 0.7%. Which means I'm 0.7% low. All right, so that's how you do that, and that's error calculations. Now the other thing you're going to do in the experiment is you're going to do a glassware comparison, and I believe we only did one of these two, and you'll have the data to look at. But all you're going to do is you're going to pour from this flask to a beaker to a flask and measure it. A beaker, oops. A beaker looks like this. A beaker is not really designed for measuring. It's a container. And it's going to have marks like this, 10, 20, 30, 40. And what you're going to do, you have some water in a beaker and you're going to read it. And let's say, okay, that looks like about maybe 24. Then you're going to pour this into a cylinder. And the cylinder is going to say 21, 22, 23, 24, 25, and it might go like this. It might go, okay, I say, oh, look at that, it's 24.5. And then you can calculate the error between these, and this is my actual, and this is my observed. And you're going to do the same thing with a flask, although the data we're giving you, we're not giving it to you for both. We're only going to have you do one of these. Whoops, that's a terrible flask. That's a better flask. All right, and flasks like beakers are marked off 10, 20, and so on. So you do the same thing, pour some liquid into there. And then the last thing you're going to do, and there's a video of how to do a volumetric pipette, is you're going to pour water, take water out of a cylinder, put it into measure in a volumetric pipette. A volumetric pipette, the one we're using is 25.00 mils. So they're precise to the hundredths place. And there's a video that shows you how to do all that kind of stuff. All right. Now I'm going to make a second whiteboard video on how to draw graphs, but that's what this lab is. It's just looking at water and just getting used to measurements. It's very important that you record measurements to the right number of significant figures, because that tells everyone how precisely it was measured. That's why this is important. It's not about how much water is in the beaker. It's about how do you record how much water is in a beaker. And just the last little speech about this, in the age of the handheld calculator, right, when everyone's got a calculator and they give you 18 digits, well, how many of those digits really mean something? So measurement is a little bit different than just raw numbers. That's why this lab is important. Learning to work with significant figures is a pain, but it's really important. And as you progress in chemistry, it's going to become more important. All right, that's this video. The second video, whiteboard video, will be on drawing graphs.